Hello, everybody. Welcome to an episode of Rethinking Resources, in which we will be discussing something that is a bit counterintuitive about the green energy transition, namely that the switch from fossil fuels to renewables is being made possible by plastics. Plastics have long been demonized by environmentalists, but modern polymers come in many forms, and critics might need to rethink their opposition. Even though they still originate from fossil sources, innovative new plastics are more sustainable. They are increasingly circular through the integration of recycled materials. And they are the key link between old energy and new energy. Another fact we have to face up to is we live in a wired world, and it is going to be getting even more wired in the years ahead. So, the example we will be concentrating on in this episode is the plastic used in the production of wires and cables. Whether their contents are metal or optical fiber, the flexible protection and insulation that allows them to carry our power, our information, and our innovation is made of plastic. But these aren't just any plastics. This stuff is special. To tell us more about this technology and the role it is playing in the energy transition, we're joined by Bart Verheule, the Global Marketing Director for Energy at Borealis, a plastic and chemicals giant that is one of the world's leading providers of polyolefin solutions. Bart Verheule, welcome to Rethinking Resources.
Thank you, Steve, for having me on the show and talking a little bit about the excitement going on in our industry.
Thank you for joining us and being here face-to-face in our studio. Tell us first, in a nutshell, what role are plastics playing in the energy transition?
I think you have explained it already in the introduction. So basically there are two functions for plastics. Is the insulation of electricity and the protection of cables. So if you can compare it in your house, where you take an electrical cable, even if it's a small one, you don't want to get electrocuted, yeah? So it's really protecting and insulating the electricity going from A to B. So you don't want to have any interruption in between. So that's what the main function of our materials is.
And there doesn't appear to be an alternative. It seems like this is the best material to use as insulation, and it's flexible. So an alternative, there's nothing else that could be used, right?
There have been alternatives before, long time ago. It was covered with paper insulated electricity cables. Yeah. And if they went up to higher voltages, they were filled with oil, but that is not used anymore today, only for rare applications.
Okay, so just for the record, is it too much to say that the transition from fossil to renewables actually cannot take place without plastics?
Affirmative. Yes, it cannot take place unless, as I said before, you would go back to old type of cables with paper-filled old cables. They are not used today anymore because they are taking too much oil. Their oil is leaking out of the cables if you go into higher voltages, and it's very slow in production. And today there are no equipment anymore to make them on a smaller scale.
Okay, so there have been some pretty exciting new developments recently, so let's shine a light on some specific examples. At the end of April, 9 European countries signed the Ostend Declaration. This is pretty big, a commitment to jointly produce at least 120 gigawatts of offshore wind energy in the North Sea by the year 2030, and at least 300 gigawatts by the year 2050. So help us put these gigawatts into perspective. For a layperson like myself, what's a gigawatt and what does it mean getting to 300?
I think excellent question, Steve. 1 gigawatt, I always compare it nuclear power plant, most people know. So the average power that the nuclear power plant gives is 1 gigawatt. Yeah, there are new technologies that go up, but 1 gigawatt. Wind is not blowing the whole time. Yeah, so you need more wind capacity to equal the same amount of power as a nuclear power plant. So I would say roughly 2.5. Yeah. So if you divide the 120 gigawatt by 2.5, then you have the amount of nuclear power plants that you would need to build in order to reach the same kind of capacity. So almost 50 nuclear power plants you would need to build to compare it with 120 gigawatt of wind. 1 gigawatt of nuclear power plant gives 750,000 households electricity. Yeah. So if you talk about 120, 300, we are talking in millions, tens of millions of households that are being powered by wind offshore.
Okay.
So it's huge.
Yeah, it's massive. Thank you for putting that into perspective. So where does Borealis come into the picture? And what specifically is Boardlink? What are its special properties? Why is Boardlink a game-changer technology?
So first, Borealis is in this business since 60 years. This year, we are celebrating our 60th anniversary, being active supplier to the wire and cable industry. Boardlink is based on what we have built over the years, and basically, I would say, is based on 4 pillars. Step change innovation, continuous investment in production of ultra-clean polymers, people, and partnerships with our customers.
Okay, and where's Boardlink being used?
Boardlink is predominantly being used in power cables. Yeah, so that's where we are mainly using this type of technology, this combination of these 4 pillars, as I said. I can give a few examples what it brings. If you look at step change innovation, what we do to facilitate cable industry is to make cables lighter, to produce cables faster, to produce cables with less waste, and to increase the power that can be transmitted through cables. Perhaps I give a couple of examples to bring it a little bit more tangible. If there are no bad cables, so all the cables have to comply certain standards. So the question is, how can you improve that further?
Okay, so there's a minimum standard. So we're moving up from that. So
Yeah,
when you say there are no bad cables, we have a standard industry. Okay, so please carry on.
To secure the people at home, there are no bad cables unless there is fraud, but there are no bad cables. So if you take offshore wind, for example, these are long cables. The weak part of these cables is the joints. Yeah, we have a special technology based on Boardlink technology that you can produce very long cables. We have an example of a cable producer in Asia that has been able to produce a 500 kilovolt, 500,000 volt cable, 20 kilogram per meter cable for more than 20 days non-stop. And this allows
continuous production for 20 days straight.
Continuous production without stopping. Yeah. The production manager was very awake and very tired afterwards.
Just the coffee consumption must have been okay. Yeah.
But they were able to make 60 kilometers of the cable, so they could connect from shore to the wind farm in one go without any joint. The joint is the weak part of a cable system. So any distance that you can do without joints is a win, and it reduces the risk of electrical breakdowns, which nobody wants.
Okay, let's touch on another specific example, this 2GW program of TenNet. 2GW, I guess, 2 gigawatts, now that I'm a pro on gigawatts. So this involved the awarding of a framework contract for cables valued at around 5.5 billion euros. This is a record in the history of the sector. It resulted in an order of 7,000 kilometers of cable systems. Tell us more about that and Borealis's involvement.
So again, taking some steps back, this is about DC technology. Yeah. Borealis pioneered in the development of DC technology. Now, what is DC technology? You have 2 types of electrical transmission, AC, alternating current, and DC, direct current. AC is normally used. Everybody uses it in the households. The disadvantage of AC is that if you transmit power over longer distances, you lose electricity. And this is where DC comes into play. So why is DC not always used? Because you need to bring AC to DC first, and then DC to AC again, to enable to equip the material that we have at home or in industrial processes. And these transformer stations, they are hugely expensive. So there is a kind of a trade-off when DC technology is being used. Borealis has been pioneering over the years. And I said step change technology is one part of Boardlink. And this we have, for example, reached this record 525 kilovolt in 2014. Then we have been able to be the main supplier for the German corridors, which is bringing electricity from the North Sea to the south of Germany. And the TenneT 2 gigawatt program is a succession of that. So we are very privileged to be part of that. And again, it's based on DC. The difference with the German corridors is that now it's going to subsea. So application. So this is part of also the 120 gigawatt pledge that these 9 countries have made. And we will go now more from point to energy islands. That is really the new thing. Yeah.
So energy islands, I can't let that come and go because it's such a great image. Energy islands. So these are windmills out at sea. This is what? How do energy islands work? They form a network that is going to be a big part of the energy transition.
Excellent question. So wind power has been reducing in cost over the years. So now renewable electricity is basically cheaper than fossil. But it has become cheaper and cheaper because there has been optimization in every single step of the renewable electricity. These energy islands is another step in that same direction to make these connections more affordable. What happened in the past was that you had a wind farm, single point, and that the electricity was brought to the continent, to shore, in one single connection. And then, on the other hand, you had interconnections between countries, UK, Belgium, the Netherlands, Denmark, Germany, Denmark, for example. And now they are actually combining these two functions. So not only connecting wind farms to shore, but having an energy island, which becomes kind of a switch between a wind farm and another country. So this is the first step. We see the Belgium, it will happen. I've seen the models. 2025, it will be there. That will be the first one. Denmark has planned 2 of them. So these are not just speculations. Yeah, there are project managers on this. I've spoken to the Belgian guy some weeks ago, and they're super excited to build this. And it was recently in the news. The Belgian utility has been allowed to make these billions of investments to produce or to develop these kind of energy islands.
Super exciting. Multinational, collaborative, cooperative. It's a good image that appears that there's hope for us after all. I said earlier that we are living in a wired world, and I wasn't exaggerating. How much wire, how much cable, and therefore plastic housing and sheathing are we actually talking about?
I would love to answer this question, but it's usually difficult, and I would have 100,000 of people complaining that I don't have it right. So I just want to give a few examples to at least give you a little bit of an idea what we are talking about. Take a house. Yeah, in a house you have around 2 kilometers of cable. 3 kilometer cable.
Per house?
Per house.
Okay.
3 kilometer of cable. If you take the global copper production, copper is used in cables. Cables represents more than 60% of the global copper production. Copper production today is 20 million tons, and there are big investments needed to make the energy transition work. So we are talking now about 40 million tons of copper needed by 2040. So doubling the amount of copper. So you can say at least doubling the amount of wire and cable that is being produced today. Yeah.
So a big increase in the coming years.
Big increase in the coming years, and that counts for the whole energy transition. Yeah. Perhaps people are not aware, but the energy transition, going to electrification, going to energy reduction, because we want to reduce the energy consumption for what we do, that will and the renewable uptake will contribute to more than 50% of the efforts to decarbonize by 2050. More than 50% will come from the energy transition.
Mm-hmm. Okay.
That's why it's so important that these 9 heads of state put their signature for this Ostend Declaration, because a lot of investment will be needed. And this will allow the industry also to invest, because today the capacity is not there. We will have to quadruple the amount of wind farms that we have done over the last 20 years in the next 8 years. Quadruple. More wind turbines, more cables, more vessels, more people. A lot of people will be needed in this industry.
Okay, so now I'm on the edge of my seat because so far we've been talking about the solution, the vision, but let's address the voices of the critics. I can't just let you and Borealis off the hook because Boardlink is part of the solution, because you're providing some solutions in this space. It's also a clear fact that Borealis is a huge producer of plastic granulate that is used to make all kinds of other plastic products. We know about the image of plastic, that it's been demonized. So doesn't this virgin granulate production sort of undermine your sustainability and circularity arguments?
Very fair question. Yeah. So first, cables, the lifetime of cables that we guarantee is 20 years. Yeah. Typically, the age of cables is 40 years. So we're not talking about single-use plastics that you use once and you throw them away. Cables are in the ground or in sea for 20, 40 years. Yeah. So this is called durable plastics, and the environmentalists will agree totally with me that these are really necessary and bring a lot of benefits. Yeah? But that's not enough. We have sustainability in the core of our strategy. So also in the cable industry, we want to take these steps. It fits very well with decarbonizing society, that we also want to decarbonize the way cables are being produced. Nevertheless, we are making a lot of pilots now together with customers that also want to contribute to a net zero pathway. As an example, we will use renewables. Renewables is our technology based on second generation bio-based feedstock. It's basically the same process as with fossil. The big benefit for us is, besides, of course, the fact that it is negative in the CO2 footprint compared to what we call virgin, so new plastics, is that you do not have to requalify the cables. So the molecules that come out of this process are exactly the same, and that allows our cable producers not to go through very expensive requalifications. So renewables that gets the CO2 consumption negative. Then, secondly, we have mechanical recycling. You talked about insulation and protection. In the insulation, we cannot use mechanical recycling, because if you recycle insulation, there will always be metal fractions. Metal fractions in a cable is not good because it can create a shortcut. So you need to have super clean plastics. The protection, however, there we are developing and launching actually this year a mechanical recycled jacket. Why are we able to do that? Because we have acquired 2 recycling companies in the last years, and they will help us to provide us with high quality, what we call recycled feedstock. So that's the protection. Then to go to circular, that would be the ultimum. So renewables, negative footprint, recycled jacket. Once the cable would be taken back after 20, 40 years, then we can use chemical recycling instead of incinerating the cable, because the main use today of old cables is to recycle the metal. And the plastic is used for incineration to provide the heat to melt the metal. Yeah. But if we can extract that and also do something with that through chemical recycling, we can bring that back into the insulation.
Such as that housing would be removed and then turned into car bumpers, or what could be done with that plastic?
We can use, again, if we do a chemical recycling, we can make the same polymer as we had before with the ultra high cleanliness. Yeah? So then it's really circular. Yeah. Mm-hmm. But it comes at a cost. So it becomes
new cable housing.
It becomes a new cable. Yeah. So and then you have a circular system. Yeah. But then you need to take all the cables back out of the ground, and that's a little bit more complicated.
You mentioned step change innovation. Specific to cables, what other advances should we be aware of?
I think I mentioned making cables lighter. Yeah, I would like to share a very nice example which can resonate to the audience. Inter-array cables. These are the cables that connect wind turbines with each other. Wind turbines are becoming bigger, so more power is being produced, and bigger cables will be needed. So we have cooperated together with one of our customers, enabled them with our material, made special material for that, to double the kilovolts that go through a cable from 33,000 volts to 66,000 volts. So instead of using two cables, they could use one cable. So you make cable lighter in that. You reduce the metal needed for that.
With the same contents inside, but through improving the sheathing housing, you can improve
the insulation.
Yeah.
Yeah. If you improve the cleanliness of insulation, you can increase the stress level that plastic can withstand, and by that you can increase the power capacity of a cable. So that was step one. Secondly, cable is in the water. Yeah. It's like if you go surfing and it's cold, you have two choices. You use a dry suit or a wet suit. Yeah? In cable, it's a little bit the same. Cables or electricity or metal doesn't like water. Yeah? So we have products that allow cable producers to create kind of wet suit cables. Yeah? In the dry suit cable, you would use lead to protect the insulation or the copper from the salt water. With the material that we developed, you can have a kind of a wetsuit cable, and you can eliminate then the lead layer in the cable, and that makes the cable lighter. So you go from 32 kilovolts to 66 kilovolts, and you go from a lead sheathed cable to a wet design cable. And that contributes to affordability and sustainability.
So let's come back to the plastics used in wind turbines and solar panels. Does Borealis also produce materials used in this type of renewable energy infrastructure?
Yeah, so we talked about mainly wiring and cables, which is the transmission part. In the generation part, indeed, we are a plastic producer. We know a lot about electrical properties. So we have launched not so long ago a new brand called Quentis that allows photovoltaic panel producers, PV panel producers, to improve the power output of solar panels. Based on the newest technology of the solar cells in particular, that's where it is very suitable for. So also there, we are contributing to make renewable electricity more affordable and fit for the future.
What does Borealis need to do better? Where's there big potential for room to the upside? What does Borealis really need to do better in this space?
We need to continue to improve in the long-term potential of electrification. So if you remember the example I gave on this DC technology, this goes back 20 years. Yeah? So Borealis really needs to have the courage, needs to continue to have the courage to invest in the future. Yeah? investing in visionary projects, supporting visionary projects. We mentioned about the energy islands before. This, for me, is the first step. Yeah, if we can support somehow, yeah, in the role that we have in this industry, to connect globally continents. Yeah, because the biggest challenge for renewable electricity is the intermittence. Sun is shining, sun is not shining, it's dark, wind is blowing, wind is not blowing. But if you can connect continents, that's really where the golden nugget for me would be, because then you can transpass time zones. Yeah, you can bring electricity from Australia to Asia, from Morocco to Europe. And then really you are independent of energy storage, which is today a very big challenge.
Okay, so we've touched on many innovations. Where else are plastics playing an important role that people might not be aware of? What are innovative plastics really capable of?
One example I can give you is something that you don't see, is what we also offer into the market is film capacitors. Film capacitors can be very small, can be very big, and they're always used to transform electricity. This is ultra clean polypropylene, and we are the global leader in this field, have been for many, many years. And recently we are also developing a plastic that can withstand higher temperatures. Mm-hmm. What does that mean?
What does that mean?
If you can reach higher temperatures, you can reduce the use of plastic, and you can make the transformers or the capacitors also smaller. Yeah, and you can also potentially substitute precious or more expensive materials, just like ceramics that are also being used in this industry.
Okay. So now's the big vision phase. Let's time travel forward to the year 2050. Are we really net zero in 2050? And if so, how did we get there?
The technology was there. The courage, and this is what made, if I'm in 2050 looking back, what made the big difference is that the politicians had a long-term vision, that energy transition was the way to go, and they shaped the regulation to change consumer behavior. Nobody wants to change, but you need to have regulations that forces change, people to change behavior, to use electricity when you need, when you can, when it is available, to create these regulations, but also to create the climate for investors to invest in the capacity that will be required, that was required, and it happened. Yeah. So belief in that it was possible, shaping the regulatory context, and allowing investors to put money on the table.
So there were a lot of question marks in your vision. Will we get there? Will we get there?
Yes. There is no lack of appetite from financial institutions. And now I'm not looking back, but I'm looking today. When we are speaking with financial institutes, there is more money than projects. So there is really the financial will, the regulation, the permitting, and that's where the politicians come into play. That needs to, that will really unlock the full potential.
Bart Verheule, thank you so much for sharing your thoughts, sharing your ideas with us, and your insights on Rethinking Resources. To everybody listening to the episode or watching on the OMV's YouTube channel, if you have feedback for us, if you have questions, please send us a message to podcast@omv.com. We would love to hear from you. For more background information on the topics we discussed in this episode and on our guest, Bart Verheule, check out our show notes where you will find links to lots of valuable information. Thank you so much for sharing your time with us. We hope you will join us again for the next episode of Rethinking Resources.